What's up with y'all boys, man? What's up with y'all boys, man? What's up with y'all boys? Hope y'all boys doing good. Hope y'all boys doing good. Okay, just pin this. So, okay, y'all. So, as y'all might know, or as y'all might not know, I am a still beginner in data structures and algorithms, bro. I'm still a beginner in data structures and algorithms. So, right now, I'm gonna be trying to solve some very beginner friendly problems which ChatGPT gave me, and I'm gonna also be trying to explain them, like the thought process and stuff like that. So, make sure that you like the stream and subscribe, and yeah, I guess let's get started. So the first is find a maximum in an in array. So we're gonna have a int find maximum in array in a maximum in array, or actually maybe get maximum in array. We're gonna have our array. We're gonna have our array. We're gonna have our array, and initially we are going to set the answer to array of 0. Now we set the answer to array of 0 initially because we are going to relate afterwards. We are going to be comparing every next element in the array and trying to find some one that is greater than this. We're trying to find one that is greater than this one. So that's what we're gonna do. So we're gonna do int I gets 0, I less than the length of the array, and if we're gonna check if an array element is greater than ans, then ans is gonna be this current element. So what we did here, we're checked, so we already have ans set to the first element in the array. Now if we find an element which is greater than, if it exists an element in the array which is greater than ans, we're just gonna set ans to that element, and then we're just gonna return the ans, which is gonna be the maximum element in the array. Okay, so let's get a test array. Maybe uh we're gonna do a test array, and it's gonna be something like this, and then I'm gonna just get these numbers from here. So right now the answer we should get is 7, and we actually have to log this to the console, print this to the console, print this to the console, and there we go, we get 7. So what happens here? So first we initially set uh, the answer to be 3, and then in this loop, for every element, actually we can start from 1, and we will get the same result because because we already checked 0, right? And so if if any of these is greater than this one, we then 3 we solve. So first we have 3, right? And then on the first iteration of this, we're gonna check if this one is if the element on if the element at position 1 is greater than 3, and so in this case, it, basically array of I, this I gets this is 1. This is array of 1, and basically um when we go to it, so is 1 greater than ans? No, so it's not gonna go inside this if and set this one to answer. Then we check is 7, so this then becomes 2. Is 7 greater than 3? Yes, it is. So then answer is gonna become 7. This is index 0, 1, 2. And then finally we check is 2 index 3 greater than the current answer, which is 7. Well, 2 is not greater than 7, so we leave the answer as it is, and then we return the answer from this function, and that's pretty much it. I think I was gonna explain something else, but I forgot what it was. Uh, yeah. Okay, let's maybe go to the next one, sum of array. Okay, so oh yeah, I think there's a lot of length, and here as well, we can use so no member has no so vector has no member named length. So I think it's like this, or maybe this is only for strings. I may be wrong. This might be only for strings. Has no member. Okay, yeah. So okay, yeah, yeah. So does there is no oops size. There is no size. There is no. It seems there is no length property for arrays in C++, but if we get a string equals hello world, and then we see out I should name it. Need to name it, and then if we see out greeting that length, I think this is gonna give the length of the string, or maybe let's see. Okay, invalid use. Oh, whoops. Okay, I think I need to like give an empty space or something, or something maybe. Okay, greeting the length. Okay, maybe it's like this. I'm pretty sure. I'm almost 100% sure, dude. Okay, yeah. So we do get the length of the string, this length. So there is a length for strings, but not for arrays. Okay, so and that's basically the first problem. I tried to explain it as much as possible. Try to explain it. Okay, let's get rid of this. Actually, maybe get rid of this completely. And now the second one, which is sum of array. And let's just call it get array sum, and then just do an array, and then our I should call it total because I'm pretty sure there's a C++ sum function slash sum. Okay, maybe not. But find some values. Okay, so I guess it's not. So we're just gonna say sum. Uh, but I think there's a sum function in Python. Yeah, there's a sum function in Python, but not in C++, it seems. So here, what we're gonna do is again, this is another for loop which we're gonna run. Another another for loop which we're gonna run, and basically we're just gonna uh, we're just gonna add every element to the sum, and then we're gonna return the sum. So what's going on here? So maybe this is confusing. This is the same as saying sum plus. This is the same as saying uh, sum equals sum plus array of I. So this is just a shorthand. Just a shorthand. And what we're doing now. So first, I is gonna be 0. So we get the 0th element, which is, let's say, 3. So this becomes 3. This becomes, so I equals 0, sum equals 3. Then then I is gonna, because we increment I in every iteration of the for loop, so I is gonna be 1 and 1, and then sum is gonna be, I think, 4. Yeah, 4. Then I is gonna be 2. Then sum is gonna be I almost said 7, but it should be 11, and then the last element that's gonna be 3, and then sum is gonna be equal to 13. 3, 7, yeah, 13. Okay, so this is what we should get from. Okay, let's just run this just to make sure there's no errors right now, and then we're just gonna get array sum of array. We should get a 13 right here. Okay, yeah, so that's that one. um okay, is there more array ones? Okay, there's a new one. Oh wait, there's another. I guess I should use the stuff which ChatGPT gives. So this is 1, 2, 3. I will get 6. Next one, count even numbers. So this one, there's two ways we can do this. The even numbers. So there's two ways to check a number is even. First way to check if a number is even is a classical way, which probably most of you guys know. So the first way to check if a number is even, the first way is we just say and and divide modulo 2 equals 0. So this is gonna return. So if we have an even number, for example 4 divided by 2 is gonna be equal to 0. So this is gonna return true. So let's say num is 4, and 4 is 4 divided by 2 equals 0. So this is gonna return true. Now this is the other way, which I'm not sure if it is. Actually, this should be bool. The other way, which I'm not sure if it is faster, but it's another way too. It's even bitwise. So the other way is to say return return and one, like this. So basically what this does, we have obviously each number has a binary representation. So for example, 4 in binary is 100. Yeah, 100. So if we end and if we say if we end this, and for example if we end 4 and 1, there's gonna be 100, and here's gonna be 001. We're gonna get 0, and actually I think this is gonna be so. Okay, this is gonna be that's gonna be so this is gonna be equal to 0. Okay, so if it's equal to 0, that means it is even, because there are no because it's a power of 2 basically. And yeah, yeah, that's about it. So okay, let's just test a little bit just to make sure we don't mess it up. You should get 1 or true. Okay, I don't know why this is taking so long. Maybe this is wrong. Maybe I need braces. Connection was what the heck? Let's run again. Run again. Okay, this is taking very long. Taking very long. Okay, I don't know what's going on. Maybe if we refresh. What the heck? Okay, what? Okay, so okay, let's try now. Okay, so CP and was okay. Yeah, this is num. This is num2. Okay, okay, we get 0. Okay, I think this is gonna have to be inside this. Yeah, now we get 1 now. Why this is inside this and it's not in, and can be like this? That I couldn't tell you. You're gonna have to. I couldn't tell you that. You're gonna have to research that by yourself. But yeah, this is 2 ways to check if a number is even or odd. I mean, you can call this is odd, and then you just gotta say equal to 1. Well, it's not. So we're checking if it's even right now because the problem statement is count even numbers in the array. So yeah, and count numbers. And I am going to use the is even bitwise because I'm pretty sure it's faster, but I'm not completely sure. but you'll just say counter r. Counter is gonna be 0. Let's even be extremely specific with our naming. I mean, we can just do an array, we can just do, or we can even do for number. So I forgot what this is called, but this is another way to iterate through an array or a map or a set even, I think. And you can just do this, and if we say if is even bitwise of this, we're gonna increment the counter. Yeah, so we can do this, but I'm pretty sure we cannot forget semicolons inside of C++. Inside JavaScript, we don't need to put in semicolons, but not here. And okay, what? Oh yeah, I'm not returning anything from the function. So it says no return statement in function returning non-void. So I need to return, and that's basically it. And then comment this out, and we should get the count even numbers, get the result. Now this is faster than inline, so that's why I'm doing this. We should get the result, and then we get 2, so it's 24, which is correct. I mean, in this we don't really sum up anything or whatever. I think this one's clear. Okay, so next one is count vowels. Okay, so this one is easy again. It practice conditions. So yeah, so count vowels. I'm just gonna do count vowels and then in a string s. So this is called passing by reference. I'm doing this so it doesn't create a copy of the variable each time, because I'm pretty sure that's gonna lead to extra space complexity or something. Not sure though. So we got uh this. Okay, so we don't need the arrays anymore for now, at least. Let's say is equal to hello. uh we're gonna have our answer. Okay, we'll call it counter again. I'm gonna return a counter, but before we return, we will actually need to count. I'm gonna have a for loop, and to make it not as confusing, let's just use good. Also, actually, we can use length when we work with strings. I don't know if it's faster, if it's more efficient. I have no idea, but it still gives you the length of the string. We can also use size like for a vector, but let's use length here. Why not? Let's use length here. Why not? And then uh, so what we can do is we can make it a vector of int I vowels. And what you're actually gonna think, oh, isn't this gonna be, if we make an array of vowels and we just set it to A to A to E to E to I to U to O and to Y. So what you actually might think is you might get tricked here and think, well, if we iterate, okay, this should be, if we iterate vowels, if vowel, if s of I equal to vowel, then we're just gonna say counter. Okay, and you might think, well, this must be in O of n squared time complexity, right? Because we have this for loop and then we have this for loop, but no, you'll be wrong. This is actually an n plus n time complexity. N plus n time complexity, which is 2n time complexity, which when we calculate time and space complexity, we remove the constants, which is just gonna be O of n complexity, right? Which is gonna be O of n complexity. So yeah, basically, so the size of the string can change many times. So this is definitely n, and this is also n, but it's actually 1 2 3 4 5 6. It's always going to be 6. Vowels is always going to be 6. So actually I guess it's more like n plus 6 or something, but and that's constant. So yeah, it's basically, long story short, this is basically O of n time complexity. And we should get the correct answer. We should get the correct answer. Count vowels of hello, which is 2. Which is 2. Okay, what reference of type string? Okay, cannot bind non-constant value. Non-constant value. Okay, then let's do it with. Oh, we didn't say it. We should say S. Okay, that's 2, and let's just add some 1 2 oops 1 2 3 4. This is gonna be 6. It's gonna be 6, and to get that 7, we're gonna add another E. That's gonna be 7, and then 1 2 3, and that's gonna be 4. Okay, and that's 4. Okay, so we did that one. I mean, yeah, basically I don't think there's anything to explain here, nothing that crazy. We just check if so for each uh, character of the string, we compare it against all the vowels. If that character is a vowel, if that character s of I is a vowel, we just increment the counter and then we return as it, basically. Okay, reverse string. Okay, this one we can just use a built-in function. So users dot beginning s dot end. We can just return s, right? So reverse string, you can just say string s. We can just, okay, we can return s, but we can also say just reverse. If we pass by reference, we can say just reverse, right? So but here we pass by value, so return it. So we can use the uh, this string as an example, and I'm gonna get Oleg, triple Oleg, or we can do string reverse string manual, which if you don't know about, if you're not allowed to use the built-in function, which it is recommend, if you know built-in functions, it is recommended to use them and not to write your own algorithms, because you might mess up and you might also not remember how to write all of them. But yeah, this one's pretty simple, so you should be okay. So we can just say string reversed, and then for just I no, actually to reverse this we want to start at the end. So, and then we're gonna say it's greater than or equal to 0, and then like this, and then we just say plus equal I, actually s of I, because if we set plus equal I, we'll get an error. So, and then we're just gonna return the reverse string, and let's go reverse string, make it even more concrete with what we're saying. So yeah, hey, thanks y'all for the 10 views, bro. Thank you guys for the 10 views. Okay, so we got how many views? 10 views. Okay, nice. Okay, so reverse string, this is basically it, I think. And let's do another string. String is gonna be s1. I'm gonna say goodbye, and then we're gonna see out reverse string manual. Say s1, and this should get yebdoog, yebdog, and there we get yebdog. It's actually abe dog. Okay. Alright, I think that's pretty self-explanatory. Okay. Yeah. Alright, check palindrome. Uh, there's 2 pointers. Okay, so next one, madam, so check palindrome. So this one is gonna be a bool palindrome, and we're gonna do string s. I'm gonna have a left pointer. So what do we gotta do here? So I guess there's a couple of ways. So let's try the naive one first. So it does say 2 pointers. You guys might not know what that is. So let's start the naive approach first. So what we can do is we're gonna get string reversed s. I'm just gonna basically show the dot length is no, I, or we can actually, we actually have a reverse string function right here, but let's write it again to be more this was equal so I, and then I'm gonna say turn s equals to reverse s. Okay, okay, so now we're just gonna um now we're going to, so we can check if, okay, let's comment these out. We can check if uh is palindrome for s, is palindrome for s. We can check this and we're gonna get 0 because it's not. Oh wait a second, there. Yeah. So we get 0. Okay. Let's try Madam now. They should give 1. Okay. So that's basically the more naive approach, you could say. I mean, it's still all in, but you're using extra space because you're making a new string, right? You're making a new string, so you're using extra space. So you're using extra space. So what if the interviewer tells you, okay, you can't, nice, but you can't use extra space. So if we want to not use extra space, uh, we've gotta do something. Is palindrome optimal. Let's call this naive, and then we're gonna do this. Okay, so we're gonna get s again. So we're gonna say, now we're gonna have basically two variables. One is gonna be called left, and the other one is gonna be called right. Now left is going to point at the beginning of the string, which is 0, and right is going to point at the end of the string, which is as the length minus 1. So right now we're going to say left less than equal to right. So while left is less than equal to right, so we have 2 pointers, so we have left and right. Then we're going to say at this point we're going to say let's do this if s of left does not equal s of right. We're gonna have to return false, because we're gonna figure out in a second. And then we're gonna do left plus plus and right minus minus. So else we're gonna return, if we survive this while loop, we're gonna return true that the string is a palindrome. Okay, so basically yeah, so this might be a little confusing at first, but it's simple. So what's going on? So first left is gonna be 0, right? So we check, so we have example, let's say we have madam, so we check m, and right is the length minus 1, so this is m, so this is left, this is right. And then we check, is left not equal to right? No, it's not. So we increment left, so that becomes a, and then we decrement right, so right becomes a. So is this not equal to, so is a not equal to a? No. So we keep, so we just increment left again. So left is d, we decrement right, right is d. So is d not equal to d? No. So we increment a, so increment left, so left becomes 0, 1, 2, 3. Then we decrement right, right becomes 1. So now left is greater than right. So we break out of this loop. So this loop ends because the condition is we're gonna do this while left is less than equal to right, and then we're gonna return true. So we return true because we didn't return false here. If at any point the characters at the two ends of the string did not match, we're gonna return false, and then we return true, and that's basically how that works. Yeah. Okay. So that's basically it for that one. I think I explained it pretty decently. Okay, next one is hash map dictionary. Okay, so we want to count the character frequency inside of a hash map. Now, this is something which is very helpful because I've actually encountered a good number of problems where you need to count the frequency of characters in a map to solve them. So, and by the way, when using C++, when you can, make sure that you include this bit slash sdc++.h, because when you include this, you don't need to include, or when you include, gotta include vector, or then I gotta include freaking stack, then I gotta include algorithm for sorting and stuff like that, for sorting and reversing. No, basically every header which you're gonna need, like vector stack, map, everything is in this uh library or whatever it is. So that's why we do this one. Okay, all right. Okay, here's a character frequency counter. So with this one, we just make a map. We're gonna make a map. So we're gonna print a map. Okay. So we're gonna do. It's gonna be a void because we're gonna print uh free count frequency of characters in string, and it's gonna have a string s. Have a string s like this. So we're gonna make our map. We're gonna have a char. We're gonna have an int of m, and then make it char frequencies or C's or something maybe. Yeah, you should. I mean, when you're solving, like when you're doing competitive programming and you're solving, like when you're doing competitive programming, like then you can pretty much name variables like very undescriptive names like m or a or b or c or whatever. But when you're in a coding interview, you want to actually name the variables with descriptive names. So char frequency, this is a descriptive name I use. I also call this count frequency of characters in string, but I could have just named it solve, I mean, here, and if you're just solving a lead code by yourself, but you can, I think it's good to have the habit of naming things with uh, with descriptive names and stuff. So yeah. Okay. So back to this. So A, B, C. So what we're gonna do is for, we can just say for int x of c and s, we're gonna just say if, to make it simple, if not char frequencies of c, then we're gonna say char frequencies of c equals 1, else we're gonna say char frequencies of c plus equals 1. We can just say plus plus, but we just say plus c equals 1 for simplicity's sake. And then what we can do now is for every pair in our map, in our char frequencies map, because in map it's always pairs. We have a pair of char and int in this case. And we're gonna do cout p dot first, which is the first element in the pair. In this case, gonna, well, like this we get the first, actually this needs to be auto. Like this we get the first element on in the pair, which is a char, and like this we get, and then let's do this, and then we're gonna print the second one, which is an integer. So basically what we did, for each character in the map we counted the frequency of that character. So every time we get a new character, we initialize an entry in the map for that character. So with the character, and then it's gonna be initialized to 1. And every time we encounter it again, we're just gonna increment this count by 1. And then that's basically our function. It should work. Let's see what they give here. We get a b c c. We should get a 2. Should get a 2. Get what I said. Count pretty long name. We're gonna say s here. We should get a 2b1c2. Okay, what happened? Okay, misspelled that. And we'll get a 2b1c2. Okay, that's basically that. Okay, y'all, and we have only like 12 minutes left. We got only like 12 minutes left, so I think I'm gonna try to breeze through these last ones. Oh, no, I'm gonna try to explain these ones as well. So, I mean, we check if numbers are even. I mean, we already basically did this one. We already basically did this one. So where was it? Where was it? Is even, okay? Is even bitwise. So basically, we checked if the number is even uh with a bitwise operator, which is the AND operator. So we're not gonna do that one. Instead, we're gonna do count set bits. Okay, so what is a set bit? A set bit in the binary representation of a number is a bit which is the 1 bit. So each 1 bit is a set bit. So this has two set. This is the binary representation of 5. It has 2 set bits, 2 bits which are 1, 2 bits which are 1. Okay. So let's do this. Okay, so let's say count set bits. Oh, and let's name it n for simplicity's sake, and then we're gonna say counter, then while while n if n1 counter is gonna be plus plus, then n by equal 10, and then turn the count. Okay, so it might be. Oh, oops, my bad. I gotta do this. Okay. So basically, what we do here. So this is just the counter that when we start the counter at 0, we're gonna count every set bit. That's the easy part. When that's the very easy part. Oh, oops, oops. Then we get n and 1 counter plus plus. So what this is gonna be if we end a number with 1, if the last when the last digit, okay, wait, no, that's for uh when, so basically when we end this with 1, we're gonna get this. So basically when we have 101 and end it with, and then end it with 1, which is 001, we're gonna get, so at 1 and 1, we're gonna increment the counter, and this is called a right shift. Basically what it does is it shifts the bits of the number to the right. So right now it's 101. When we shift to the right by 1, it's going to become 10. And then what we're going to do is 10, and 01. So are these two, so this is not matching, so it's not going to count. Then it's finally is going to shift, it's going to shift to the right one more time, so this number becomes 1. So it becomes 1, it becomes basically 1, 1. And then 1 and 1 is true, so we're gonna get counter plus plus, and that's how we get the counter. And that's how we get the counter, and that's our answer. And now it should see how do you call it, count set bits of 5, we should get 2. Should get 2, okay. Next let's try 7, we should get 3. Okay, let's try, what should we try? 15 should be 4. Okay, and then 16 should be 1 because it's a power of 2 also. Okay, so that's that. We went to these, blah blah blah. Okay, yeah, more done. Okay, so find minimum. Okay, this I think is gonna be maybe the last one because we got 7 minutes. Um, thank you all for the 15 views. Thank you all for the 15 views. How do I look at the likes though? I don't know how to look at the likes. Okay, whatever. So find minimum in array. So I'm gonna say get array minimum vector int I. So yeah. So basically, bro, for the longest time when using C++, I didn't know how to create a dynamic array. So vector is a dynamic array in C++. We have static arrays, we have dynamic arrays. This one is a dynamic array. I almost said static array. It's a dynamic array. So I'm gonna get min. Actually, is there not a min functions plus plus? Pretty sure there is, right? Yeah, there's a min function, so we're gonna call it, instead of min, let's call it minimum equal to array of 0. I mean, this is basically, we already solved the array dot size. We already solved the maximum. So it's basically the same, except we change the sign here. Instead of greater than, it has to be less than, right? So yeah, how do I close this? Okay, so yeah, so if array of I is less than minimum, then our minimum is gonna be equal to array of I. And we already I already taught you guys how to do the maximum. So the minimum is pretty easy after you figure out the minimum is pretty easy after you figure out how to get the maximum. Yeah. Okay. So now we have this array. Oops. We have this. We're gonna just delete this. So vector int array like this, and then we're gonna do this cout with array. Then we're just gonna do this. Okay, so we get 1, and that's the minimum. Now let's say minus 12. No, it should be minus 12. There we go. That's the minimum. Okay, last one, the count odd numbers. So let's use the module this time, because I don't know if you guys got the bit. I think the bit one is count odd in array odds vector int array. Let's use the counter for int get 0 I less than array dot size plus if array of I to 2 equals to 1. Actually, we're gonna do counter plus. So this is a remainder. So every number when you divide it by 2 is gonna every odd number divided by 2 has a remainder. Of 1. Yeah. Every odd number when divided has a remainder of 1. So we're gonna return counter here, and we should get 1, 2, 3, 4. 1, 2, 3, 4. So count odds in array. Should get 1, 2, 3, 4. Actually, no, 1, 2, 3, 4. Oh no, 1, 2, 3, 4. Yeah, 4. Okay, we get 4. Okay, let's remove 1. Should be 3. And then let's add 1, 2, 3, 4, 4. Actually 11, 15 or something, and then it should be four, seven. Yeah, there we go. Okay, guys. So that was it for today. We hit the 1 hour mark. Actually, I think I'm gonna start trying to explain these more. Because I think the time went faster by that way. So yeah, make sure to like and subscribe and